brought to you by Thomas Allgaier and Frennis. This edition highlights key LinkedIn posts on next-gen vehicle intelligence in weeks 41 and 42. Frennis supports automotive enterprises and consultancies with market and competitive intelligence, decoding disruptive technologies, customer needs, regulatory change, and competitive moves so product teams and strategy leaders don't just react, but shape the future of mobility. Welcome back to the Deep Dive. Today, we're diving into next-gen vehicle intelligence, pulling out the key insights from what we've seen discussed online over the past couple of weeks.
Yeah, it feels like the conversation's really sharpened, doesn't it? There's definitely less talk about just throwing features out there and much more focus on, getting the foundations right, scalable platforms for AI, software, the whole cockpit experience.
Right. So our mission here is to kind of filter through all that noise and give you the core strategic takeaways. We noticed the big battles kept coming up like build versus buy and getting real about data.
And it's critical to get this right now. The scale here is huge. I saw a post from Swaraj post-sale framing the automotive software market. $19 billion last year.
Wow.
Yeah, and expected to hit something like $32.3 billion by 2030. So if you make the wrong platform bets now, well, fixing it later is going to be incredibly expensive.
That really does put a fine point on it. Okay, let's kick off with maybe the trickiest area for a lot of companies, SDV architecture. That whole build versus buy thing just won't go away.
Software-defined vehicles, yeah, SDVs. Basically moving intelligence into centralized code away from fixed hardware. But actually doing it. That seems less about the tech itself and more about, internal politics and organization.
And there are some pretty stark numbers floating around about this. Maximilian Wenner shared some findings from Andreas Heinecke, I think it was from eLobby 2025, about where the actual effort is going.
Oh, yeah, that was eye-opening.
Get this. 70 to 80% of SDV development capacity is apparently spent on the foundational layers.
Right, the plumbing. Connectivity, security, middleware, OTA updates, basic analytics, all necessary stuff, but it delivers absolutely zero visible value to the customer.
Exactly. It's not what sells the car. So only, 20 or 30% of all that engineering time and money goes into the actual features people see and might pay for?
Which begs the question, if hyperscalers like AWS or Azure offer robust, scalable infrastructure already, why are OEMs pouring resources into building those non-differentiating bits themselves?
It seems massively inefficient.
Well, that inefficiency is forcing the rethink. If you can just buy reliable infrastructure, why reinvent it? Why sink billions there?
Okay, I see the logic, but we keep hearing the tools and methods are actually ready. Robert Fay noted this. If the tech solution is there, why is it taking so long to change?
Yeah, because it's not really a tech problem. It's political, deeply political. Peter Wendorf had a great take on this. He talks about non-decision making.
Non-decision making.
Yeah, essentially the defenders of the status quo, maybe folks rooted in traditional mechanical engineering using bureaucracy, committees, inertia, basically anything to slow down radical change and protect the old ways.
Organizational drag. That makes sense, especially when speed is so crucial now. So the way around that internal friction is working together. Standardization.
Exactly. Standardization is like the WD-40 for the organization here. Look at the Eclipse S-Core project Andreas Kaluza detailed.
Right. That involves BMW, Mercedes-Benz, Electrobit, some big names.
Yeah, building a modular, safety-focused, open-source foundation.
Yeah.
The idea is let's share the stuff that doesn't differentiate us, that 70-80%, and free up our engineers to focus purely on what makes our cars unique.
Okay, but shifting heavily to open source, that opens up a huge can of worms around liability, doesn't it? Vinicius Saduzine brought this up. If maybe 70% of the code is OSS and those licenses typically say no warranty, what happens when something goes wrong? Who's on the hook? The car maker, the tier 1 supplier, the open source community?
That's the million-dollar question. And the consensus Dine mentioned seems to be heading towards a hybrid model, kind of like enterprise Linux,
How so?
Instead of using raw community code directly in critical systems, OEMs would use commercially supported distributions. These vendors provide a validated stack, long-term support, security updates, and crucially, contractual liability.
So you buy the support and the liability wrapper along with the code?
Pretty much.
Yeah.
You design liability into the sourcing process rather than scrambling after an incident.
Seems like a sensible approach. Okay, that architectural stuff is clearly a massive ongoing headache. Let's switch perspective now to what the driver actually sees and feels. Theme 2, AI, HMI, and the conversational cockpit.
Yeah, the big shift here, as Syed Feroz Raza put it, is thinking of AI as the new OS for the customer experience. Moving away from digging through menus, towards interactions that are more proactive, based on understanding intent. The car should sort of anticipate what you need.
And we're seeing major OEMs jumping in with sophisticated AI pretty quickly. David Richardson mentioned GM expanding its AI efforts, linking future eyes-off driving goals with conversational AI using Google Gemini specifically.
And Mercedes just launched something significant too. Steve Basra and Magnus Osberg were talking about the new MBUX virtual assistant in the CLA.
This isn't just basic voice commands, right?
Not at all. It integrates large language models Gemini, again, directly with things like Google Maps, so it can handle really complex contextual stuff.
Well, like what? Give me an example.
Like asking, find a vegan place for 8 people not more than 10 minutes away from here.
Yeah.
That kind of multi-layered request. And apparently, they got this complex system market-ready in just 10 months.
10 months. That speed is becoming a weapon itself.
It really is. But there's another layer of complexity. The ecosystem is fragmenting globally. Magnus Osberg also pointed out that somewhere like China, it's a completely different digital world.
Right. You can't just rely on Google or what's up there.
Exactly. So Mercedes has to completely localize the cockpit stack. They're using platforms like AMP and local AI like ByteDance's Dubao just to match how users behave there. It's not just translation. It's adapting the entire digital interaction.
A huge localization effort.
Absolutely. And looking even further ahead, Vijay Thopai mentioned agentic AI, using things like the Strands Agents SDK.
Yeah.
This is where the car becomes less of a single assistant and more like a team of specialized AI agents.
A multi-agent system.
Yeah. You talk to the car naturally, and different agents handle safety, comfort, navigation, entertainment, all working together proactively.
That sounds powerful. But weaving all this together, the AI, the cloud, the localization, that puts immense pressure on the underlying architecture to be fast and flexible. Which brings us neatly to theme 3, the architecture of speed.
Right. 2 big problems to solve here. First, where do you actually put the processing power? And second, how do you stop software development being bottlenecked by hardware availability?
Okay, workload placement first. Chauncey made a good point. Architecture first, then decide on cloud or edge, not the other way around.
Makes sense. Because different tasks have different needs, right? Real-time stuff like sensor fusion, that needs instant local processing. We're talking maybe 12 milliseconds latency.
Can't wait for the cloud for that.
No way. But big AI model retraining, large-scale analytics, that can happen in the cloud, maybe 47 milliseconds away.
Sure.
A competitive architecture has to nail both local immediacy and global learning.
Okay, and the second problem, breaking the hardware dependency.
Virtualization. Robert Fay called it a time machine, which I quite like. It basically kills that dead time developers spend waiting for physical prototypes.
So how does that work if the hardware doesn't even exist yet?
You simulate it. You use virtual ECUs. Sudhakar Melody talked about projects integrating platforms like Siemens PAV E360 with detailed hardware models like ARM Xena. This enables what they call shift-left development.
Shift-left testing much earlier in the cycle.
Exactly. You can get software for complex things like lane keep assist, pretty mature before the first physical ECU is even available. Teams can work in parallel. It just massively cuts down time to market.
Got it. But running all that simulation and virtualization efficiently needs a serially optimized cloud backend, right?
Well, absolutely. Tomislav Lazančić shared a really impressive case study from BMW. Their platform manages something like 375 Amazon EKS clusters, running over 1,300 microservices. It's huge.
That sounds incredibly complex to manage efficiently.
It was. But they adopted Carpenter, which is basically an intelligent autoscaler for their cloud compute resources. It watches the workloads and automatically adjusts the infrastructure needed.
Ends payoff.
Pretty significant. Around 12% better CPU utilization, and they saved over $1 million a year on infrastructure costs. So that back-end optimization, it directly saves money and boosts efficiency.
And this kind of centralized power is being enabled by faster networking in the car too, right? Stefano Toni highlighted Broadcom's 30Gbit automotive Ethernet switch. That's a world away from old CAN buses.
Definitely. But it's still tough going. Martin Schleicher pointed out that while server-zone architectures promise simplification and savings, many OEMs are still really struggling with the actual implementation. It's a big shift.
Which brings us back down to earth a bit. All this amazing tech needs to be grounded in reality, especially safety. Let's move to theme 4, the safety reality check. We need to talk failures, regulations, and that balance between code and machine.
Yeah, this is crucial.
Yeah.
Michael Enter Gomez had a really strong counterpoint to the software uber alles mindset.
What was his take?
He argued pretty forcefully that a car maker's core identity is, or should be, building great machines. Software supports that, enhances it, but shouldn't try to replace fundamental mechanics entirely.
And trying to make everything software leads to problems.
His view is, yes, buggy features, reliability nightmares, and it distracts companies from their core strength, building safe, reliable vehicles.
And we're seeing real-world events and regulatory reactions that seem to back this up. Yingnan Yao mentioned fatal accidents in China, like that Xiaomi SU7 incident with the door handles.
Right, where they reportedly didn't release electrically.
Yeah. And that's shifting consumer focus sharply back towards basic hardware safety. It's leading to new rules mandating mechanical door releases, for example.
And Robert Wigmo made the point that even seemingly simple quality failures, like getting locked in or out of a very expensive car,
Yeah.
often that traces back to really basic process gaps. Disconnected teams, requirements not properly verified. It's not always some futuristic AI glitch.
Meanwhile, though, ADAS reliability is becoming a huge competitive factor. Javed Khan announced Aptiv's Gen 8 radars, specifically for hands-free driving in tricky situations.
But the real differentiator seems to be the data used to train these systems. Bruno Fernandez-Ruiz introduced Nexar's BATIS 1.0. They achieved better incident prediction.
How? By training on an absolutely massive data set, 10 billion miles driven, 60 million unique driving events.
10 billion miles. That just dwarfs what you can get from simulation alone. It really proves the power of large-scale, real-world fleet learning for ADAS safety.
And it's a good reminder that even the absolute basics are critical. Frank Turlip emphasized camera calibration. Seems simple, right?
You'd think so.
But a misaligned camera, even a smudged lens, it can completely mess up ADS functions, false warnings, or systems just shutting down. Doesn't matter how smart the AI is if the input sensor data is bad.
Exactly. The physical machine and the human process around it, they still have to be absolutely solid.
So let's try and pull this all together. What's the big picture? It feels like the industry is definitely pushing towards standard virtualized platforms. They're going big on AI for personalization.
Yeah, but at the same time, they're really wrestling with these deep questions about liability for shared code and even their core identity. Are we primarily software wizards now or still master machine builders? It's a real tension.
And this software focus is even hitting the factory floor.
Right. Julina J.T. Wozniacka talked about the shift from software-defined vehicles to software-defined manufacturing, using AI analytics to optimize production itself.
Okay, so here's a thought to leave everyone with. If Andreas Heineke is right, and maybe 70–80% of internal SDV effort is currently spent on infrastructure that OEMs should be buying or sharing, and if the final customer experience increasingly relies on these big, collaborative, open ecosystems,
then the provocative question is, when most of the underlying code is shared or bought, where does the unique, sustainable competitive advantage for an OEM actually come from in the future? What really makes you different?
Something to think about. If you enjoyed this episode, new episodes drop every 2 weeks. Also check out our other editions on electrification and battery technology, future mobility and market evolution, and commercial fleet insights. Thank you for joining us for this deep dive into next-gen vehicle intelligence. Hit subscribe to ensure you don't miss our next edition.